Hi there, welcome back to Pretty Much Flawless. This is part 3 of a 5-part video series on reverse engineering a PCB, and today we're going to be talking about footprints. So let's get into it.
I'm past security.
I'm in.
Hold on, what's this? A bomb?
In 5.
Quick, we don't have much time.
4. 3.
Whole bunch of wires
2.
here. Which one should I cut?
1.
This one looks good.
Detonation canceled.
Alright, go. Let's see if we fix the problem. Very good.
Alright, I'm in position. Which drawer is it?
Third from the top.
Roger that, checking now. The cargo is still here.
Check to make sure everything's okay. Hold on. Nobody told me this was from PCBWay.
PCBWay makes high-quality custom PCBs for your projects. Design and upload your Gerber files to the website, then place your order and wait a few days for your PCBs to come. And that's not all they do. PCBWay also does CNC machining, 3D printing and many different materials, sheet metal fabrication, and injection molding. Check out the website. There will be a link to that in the description down below. And if you are looking to make your own affordable PCBs, I would really recommend using PCBWay and look forward to using them again in the future. Alright, so now we have our schematic and our parts ordered. Now what we need to do is we need to make the footprint for our new parts. So what we'll do is we'll go over here to Footprint Editor. We'll click on this. What we'll do now is we'll go over here to File, New Library. We'll save this just for the project. Okay, and we will save this as Relay, single pole, double throw. Save that here. And now what we'll do is go over here and click New Footprint. Good. The footprint name will be Relay, single pole, double throw. And the footprint type will be through hole. Okay. Good. And now what we can do is we can lay out our pads here. So we'll go over here to the data sheet for our relay here. We can scroll down here, and this will give us all our technical information we need to know here. So we need 5 pads, first of all. So we'll lay 5 of those out. 1 is the common, 2 and 3 are the coil, 4 is normally open, and then 5 is the normally closed. Alright, so we have the 5 pins laid out, and here's our drawing over here. So we're going to want to flip this around. This is looking at the bottom of the relay, and if we want this to fit onto our board, we need to flip this around. So pins 4 and 5 need to be over here, pins 1 need to be over here, and then pins 2 and 3 need to be reversed, just so our relay will fit onto our board. So now what we can do is we can start measuring everything out. So between pins 4 and 5, there's supposed to be 7.6 millimeters. We'll do that. I'm going to use millimeters for laying this out, but the inches equivalent is right here. So what we'll do is we'll use the drawing tool here, and we will draw from here, and we want to make this 7.6. So what we need to do is we need to adjust our grid down to 0.1 millimeters, and now we can try again. So we're looking for 7.6, and we want to make sure this line's straight. Okay, that's good. Now what we'll do is we'll move this down so these things are both aligned and 7.6 millimeters apart. Good. So then we'll go over here and we'll take a look at the distance between pin 4 and pin 1. What we're going to do is we'll first find that between the middle of pin 1 and the middle of pin 2 here, that is 3.8 millimeters. And then we can take a look over here between pin 2 and pin 3, that is 10.2 millimeters. And then between pin 3 and middle pin 4, that's 3.8. So what we'll do is we'll just add all those numbers together. So 3.8 plus 10.2 plus 3.8 is 17.8. So what we'll do is we will measure 17.8 between pin 4 and pin 1. Good. And another thing is, between pin 4 and pin 1, there is a gap of 2.5 millimeters. So what we'll do is use our measuring tool again. So we weren't able to get it right at 2.5. We can double click on this, and then we can hit override value. And what we'll do is we will type in 2.5 millimeters here. Okay, good. So that's been adjusted. So now what we can do is we can get this lined up. Pin number 1 lined up with our 0.5 over here. Alright, so now we can work on pins 2 and 3. So if we take a look at this diagram here, between the middle pin 1, middle pin 2 here, there is 12.8 millimeters there. So what we'll do, we'll again take our measuring tool here, and we'll get this on 12.8 here. We'll make this go right across here. Alright, we'll get these two lined up right with the middle here, and then what we'll do is we will see the distance between the middle pin 1, middle pin 2 is 3.8, so we'll measure out 3.8 here. We have this right in the middle here, so that's good. And then from the middle of pin 2 to the middle of pin 3, that's 10.2. So we'll measure this. Point 2. I'll move pin 3 here. And that's right in the middle here. And good, so that's everything laid out. So what we can do now is we can just delete all our markers here. So that's good. Alright, so now we have all the pads laid out. The next thing we're going to have to do then is we're going to have to get the pad sizes right. So here it shows that we need 3 holes with the diameter of 2.1. So that's going to be for pin 5, 4, and 1. And then for the 2 coil pins, we will need 2 pins with an inner diameter of 1.1 millimeters. So what we'll do is we'll go over here and we will change these. We'll double click on these pads and this will open it up. So what we'll do now is we will go down here to the hole shape and we will go and type in 2.1. I'm actually going to add a little bit of clearance room, so I'll make this 2.2 just to have a little bit of clearance in case my measurements aren't exactly right. So that should be good. And then for our diameter, I'm going to make this 4 millimeters. So a good rule of thumb is to have about as much material on your pad as big as your hole is. So our hole is 2.2 millimeters, so our diameter is 4 millimeters. So that leaves us with 1.8 millimeters of pad to solder to, which should be plenty. So that's good. Okay, and we'll do the same thing for the other 3 pins here. So we'll go over here now, and we'll make the diameter of this 1.2. Again, just accounting for a little bit of error here. And then we'll make this pad diameter, we'll make this about 2.4. Good, so that is all our pins laid out, and everything's good there. Very good. So what we can do now is we kind of want to have our relay shape also drawn on our PCB. So what we'll do is we'll scroll up a little bit here, and this will tell us the outside dimensions of the sealed case here. So what we can do now is we can take a look, and what we'll do is we'll basically make this shape here. So we'll go over here to the line tool, draw a line. We'll go over here to give ourselves a bit of room. So we will make our line here. Our first line we're going to do is 19.6. So we'll do that. Make sure we'll have a nice straight line. 19.6 millimeters. Okay, and then the whole diagram here is upside down, which is fine. So what we'll do is we'll just draw this upside down here, and then we will rotate this whole object into the right shape, and then bring it over here so it's outside of our box here. Okay, so we'll just continue drawing. Alright, so now we have our relay shape all drawn up here. So now what we can do is we can select this whole thing, and then we'll hit rotate, rotate again. Perfect. And now what we can do is move this all the way over here and get it perfectly lined up. Alright, so this view is from the side right here, and we can see that we're 2.2 millimeters away from the pin here. So from the pin to the top. So this is the top over here, this is the bottom, and this is one of the sides. So what we'll do is we will measure from the middle of this pin, and so we're going to group all these lines together just so when we click on it and move this, all of them stay together. The group button is just right here, and what we have to select all the items. So what we'll do now is we'll get this line up 2.2 millimeters away. Perfect. That's from the center here to 2.2 millimeters. Good. And then we'll see if we can find side view here. So this is the top view right here, and then in between the end here and the middle of pin 5 here, it's 5.4 millimeters. So again, we'll take our measuring tool and we'll measure 5.4 millimeters. It's good. Perfect. So this should be exactly where it's supposed to be, and we can just double check this with our pinout here, and that looks about right. So that's good. Very good. So now what we can do is we can put our reference designator exactly where we want it. I think we'll put it along the side here. Good. And we can just delete this unnecessary stuff here. So, good. All right, one more thing we'll do is we'll want to select our entire relay here, and we'll move this so that this is in the middle right here. And this is our rotate point right here. So that's good there. And then we will hit save changes over here. And then what we can do is we'll go over to our schematic right here. And then we'll go over here to assign footprint. So then what we can do is we can go over here and search for our footprint, which is called relay single pole double throw. And then we will select from K1 to K7. So K1, we'll hit shift and go all the way down to K7 here. And we will select relay single pole double throw. We'll double click on there. And now the footprint has been assigned, which is good. So we'll hit apply, save schematic, and continue. Okay, and then hit OK. Good. So now we'll do the same thing again for our QC tabs. So all we'll do is open up the footprint editor again. And then what we'll do is we will go over here to the layout. We can go over here to our QC tab data sheet so we can enter in all the information here. So what we'll do is we'll go File, New Library. We'll save this for the project again. And we will save this as QC tabs. Good. For QC tabs. We'll create a new component here. The footprint name will be called QC underscore tabs. Footprint type is through hole. Okay. And then good. So now what we'll do is we will begin working on this. So if we take a look at our pinout here, So for our PCB, what we need is two holes with 5.08 millimeter spacing, and the holes are 1.4 plus or minus 0.5 millimeters diameter. So what we'll do is we'll design this two pads, 1 and 2. Well, let's see properties. We're actually going to change this pad number to 1 also, because in our schematic, our symbol here, both of these are pin 1, just because of the exact same thing. So what we'll do is we'll go back over here and we'll space them out the proper dimension. So I'll get this lined up right here. And that should be good there, 5.08. And what we can do is we can change the pad sizes again. So we'll double click on these, and we are going to make this 1.45. We're going to count for a little bit of error here. And I think we'll just leave the diameter at 2.4. Good. And we'll want to do the same thing again. And what we're going to do, we're going to make a box around the entire connector. So what we'll do is we'll draw a line around our QC tab just to kind of show how big it's going to be. So we will draw a box around our pads. Our pads are 2.4 millimeters wide. All right, so we'll make our box about 2.5 millimeters wide. We'll make it about 20 millimeters long. So now what we'll do is we'll get this right in the middle here. It looks like we're going to have to make this a little bit wider, just so it fits over our pads nicely. So now what we'll do is we'll put our reference designator on the side over here. And we'll just throw this on the top here. And we'll get this right in the middle here. This is our rotate point, so we have to rotate this. We want it to be rotating right in the middle here. So that's good. So same thing again, we are going to save this. And then we can go over here, back to our schematic here, and then what we'll do is we'll go over here to assign footprints. We will search this time for QC underscore tabs right here, and we'll select from J1 all the way to J26. So then what we can do is we can just go over here, double click here, and all these will show up right here, and then we'll hit apply, save schematic, and continue. Okay, and now what we can do is we can hit this button over here, switch to PCB editor. We can go over to this button right here, update PCB from schematic, update PCB, close, and then we can see right here that we have all our QC tabs here, and then we have our relays right here. So then the next thing we'll have to do is we'll make our board, and then we'll start laying everything out. Very good. Thanks for watching this video today. Hope you learned something. If you did, please subscribe. That would really help my channel, and I'll see you next time.